Good morning, ma'am. I'm Soundara from CSC D section. Subject Discrete Mathematics and Structure. Topic Properties of Group. Subtopics Introduction, Group, Properties of Group, Applications of Group, Order, Main Classes. Introduction. Group theory in mathematics refers to the study of a set of different elements present in a group. A group is said to be a collection of several elements or objects which are consolidated together for performing some operations on them. If any two of the elements of a set are combined through an operating for producing third element that belongs to the same set and that meets the fourth hypothesis, that are the closure, the associative and the invertibility and the identity, they are referred to as an group axioms. Group. A group must contain at least one element with the unique up to isomorphism. Single element group known as terrible group. The study of group is known as group theory. If there are finite number of elements, the group is called finite group, and the number of elements is called group order of the group. A subset of a group that is closed under the group of operations and the inverse operations is called as subgroup. Subgroups are also groups, and many commonly encountered groups are in fact special subgroups of some more general large group. If any two of the elements of set are combined through an operations for producing a third element that belongs to the same set and that meets the fourth hypothesis, that are the closure. Properties of group. Consider dot to be an operation and G to be a group. The axioms of the group theory as defined in the following manner. Closure. If X and Y are two different elements in group G, then X dot Y will also be a part of group G. Associativity. If X, Y, and Z are the elements that are present in group G, then you get X into Y, Z is equals to X into Y into Z. Invertibility. For every element X in the group G, there exists some Y in the group G in a way that xy is equals to y into x. Identity. For any given elements x in group G, there exists another element called in a group G in a way that x into I minus I is equals to 1 into x. When I refers to the identity elements of group G. Applications of group. In mathematics and abstract algebra, group theory studies the algebraic structures that are called groups. The concept of the group is a central to abstract algebra. The other well-known algebraic structures like rings, fields, and vector spaces are also seen as a group that are endowed with the additional operations and axioms. Several physical systems like the crystals and the hydrogen atom can be modeled by the symmetric groups. Applications. Groups recur throughout when it comes to mathematics and the methods of group theory have influenced several parts of algebra. The linear algebraic groups and the Lie groups are the two branches of group theory that have experienced advance and are the subject areas in their own ways. Hence, the groups theory and the closely related theory called the representation theory to have several important applications in the fields of physics, material science, and chemistry. Order of group. The order of the group G is the number of elements in the group G. It is denoted by G. A group of order 1 has only the identity element, that is E. A group of order 2 has element, that is one identity element and one some other element. The other well-known algebraic structures like the rings, fields, and vector spaces are also seen as the number of groups that are endowed with the additional operations and axioms. Several physical systems like the crystals and the hydrogen atoms can be modeled by symmetry groups. The concept of the group is an central to abstract algebra. The linear algebraic groups and the Lie groups are two branches of group theory that have experienced advances and are subject areas in their own ways. Hence, the group theory and the closely related theory called the representation theory to have several important applications in the fields of physics. Main classes of groups. The number of types of group studies has increased gradually from finite permutations groups. Well-known instance of matrix groups to abstract group then may be specified using generators and relations. As a result, we may classify groups in the following categories. Permutation groups. Permutation groups are mathematical groups whose members permutates of given set M and whose group operations is the composition permutations in G. Main classes of groups: matrix groups, transformation groups, abstract groups. Matrix groups. In mathematics, a matrix group is a set of invertible matrix with the operation of matrix multiplication over a defined field K. A linear group is an isomorphic group to a matrix group. Transformation groups. The term transformation group refers to a subgroup of an automorphism group. A transformation group is similar to asymmetric groups in that it often consists of all transformations that retain a specific structure. Abstract group. A presentation of generators and relations is common approach to defining an abstract group. The production of factor group or quiet group G by H of a group G by a normal subgroup H is a key source of abstract group. Thank you.